Lastly, how do our body, our environments, that there is a very specific method, right, for that science uses to inspect things in the human world and in the natural world. But we're also going to be thinking about those historical ways science have practiced viewing, have structured viewing. But we're also going to be looking back at science from the position of artists who really use the language and techniques of science in a way to express themselves, to express certain ideas about society and on how it's organized in different ways. So we'll be moving through various topics today, and so I hope you really enjoy the art that we will see. And so focusing specifically on art and science and how they interact with each other, that's the goal for this episode. You will be able to answer and discuss the following questions. First of all, how have art and science historically interacted with each other at all? And you will see that actually art and science were not that distinct in their histories. 2, how can artists use optics and perception to confuse or influence what viewers see? Because thinking about vision, which we've been thinking about a lot in this class, humans see things with their eyes. That is a way that people experience their world quite directly. And if we're thinking about science, optics and how eyes actually work is very specific, right? And you can learn how does the eye and the optical nerve process information. And if artists know how that happens, they can do some really funky things with their art that can actually make us see things differently, like very physically. 3, how have artists engaged with the power of technology and engineering, right? Technology and engineering can create, it can generate, it can interact with people. It can interact with the environment. And so we're going to see examples of artists who are really thinking about the power of tech and engineering. And then lastly, how do artists use materials to examine environmental issues? And this portion, which will be at the end of the episode, really thinking about how artists use the language of architecture, right? Architecture being this very artistic and scientific and mathematical discipline that is all about using materials to create spaces for humans to live, right? And thinking about sustainability and the environment has become a really popular topic in recent architecture, of thinking, well, how can we build differently? But also artists using that language of architecture to make us think about the environment in general. So let's get started. Just as a bit of an introduction of just art and science and its relationship, this is just me, but I think this is a popular opinion. I have an anecdote that I'm going to tell you guys about this, but oftentimes science, so the STEM fields and art in the humanities, are often seen as disciplines with very little in common. I mean, actually, in most universities at NMSU and other places, there's, they separate them. It's art and sciences, right? There isn't a word that they both are part of. That ideologically and institutionally in universities and schools, they're different. And even teaching students who take my classes, which are all about art, and it's very much part of the humanities, a lot of my students are not art majors. They're taking this class to learn something a little bit more about art, or maybe they had a class once upon a time that they really liked, but they wanted to get back into it. But a lot of my students are in the STEM fields and the sciences. And I always ask this question at the, when I teach, these lessons is, do you think that they're separate? Is that something that you've experienced? And a lot of students say, yeah, well, when you are in school, even in high school going on, that's very much, it is that separation. You kind of have to, I mean, if you are asked to choose, right, which way are you going to go? Are you going into the sciences, the arts, right? Other disciplines in the arts could be, say, history or literature or writing, not just in the visual arts. But I also noticed that when we have discussions about science and art, especially in orientations in art class, which isn't specifically art history, a lot of my students say, wow, there is so much overlap that I didn't realize was there. And so this episode is all about thinking about that overlap and where art and science are blurred, that perhaps they are actually very, very much indebted to each other, and perhaps they help each other. And there's actually a lot of research that has been done that's to say that the method of producing art, visual art, and the method of producing scientific creativity, right? The whole idea of science is that you learn a skill, a technique, you have knowledge that then you apply to, say, solve different problems. Say you're in the medical field, you learn how bodies work so that you can cure bodies or get rid of pain and these sort of things. You are asked to really use your tools in a very creative way. And research has shown that same creativity that sparks invention is also the same creativity that sparks the creation of art and cultural products like painting, sculpture, literature. And so if on the level of just psychological research into this topic, they are actually very much related. And you can think about that in terms of, even how we describe scientists and artists. Similarly, that we think about their psychology. They're smart. They can learn different things. They're polymaths, which means that they can inhale information and really use all of their tools in a very proficient way. But also people who are really good problem solvers as well. And many people who have pursued both art and science have actually reported that one discipline really informs their work in the other. And I have experience with this as well, with my students, but also with family members. And seeing this happen, for instance, my anecdote, I am very much in the arts and the humanities. My sister went into science, like scientific research, but she was very, very, very good at doing art. We were both really good at painting and drawing in high school. And in a lot of ways, I believe that my sister's foray into the the visual arts really helps her creativity, and vice versa for me. I am very interested in material science. As an art historian, I like to know how materials work, how chemicals work, and for me, that allows me to understand art better, of understanding, well, how can certain materials be applied? How do they deteriorate? And for me, that gives me so much more information and understanding of the images and the objects that I see. So they really do influence each other, and not as an advertisement, but I highly recommend, if you are someone who's in the sciences or in the arts, to take classes or at least a class in the disciplines and see how it goes and see if it influences you in some way. But if we're looking at the history of science and art, they have actually been intertwined, going back to the Renaissance. So Europe during a few centuries, but mainly the 15th and 14th and 15th and 16th centuries, when this idea of science and humanism, right? These different philosophies that we need to focus on learning them. Artists were proficient in making art, but then they also had to be proficient in inventing new technologies of philosophy, of poetry. You were asked, you could not just be a scientist or an artist. You literally had to be everything, right? You had to be a polymath. And so many really famous historical artists were scientists. And but even now, when we're thinking about, if we're thinking about modern and contemporary art, so art of the more recent times, there has always been collaborations with scientists and engineers to really help artists make their vision possible and to create the effects, right? Either the artists just learning this knowledge themselves, or like I said, getting help from the STEM fields. And so today we're really going to take a little journey through the history of science and art. And we're going to introduce its early instantiations, and we're also going to look at more current representations. And so the themes that we'll go through: when artists were also scientists, optics and perception, technology and engineering, and material and environmental science. So, beginning with when artists were scientists and when scientists were artists. And here is an example from it's a botanical drawing, and that's a keyword for today. One of my favorite illustrators, scientific illustrators, Maria Cibala Marian. And she is a really kind of rare example of a woman artist, but also scientist, which was very uncommon during this day, who was very popular and very accomplished and very celebrated. And she was a traveler, so she was a natural scientist. So she was really interested in the life cycles of different types of plants, but mainly insects. She was very interested in insects, caterpillars, butterflies, and of course insects interact with certain botanicals. And so she was also interested in, well, what do they eat? Where can we find them? And so her drawings are very, very intricate, very detailed studies of different insects, butterflies, and the plants that they eat. And in a world before the photography, where you could actually just photograph a caterpillar and as a way of documentation, well, if you didn't have that, you as a botanical researcher had to actually draw it yourself. And the more detailed details you draw, the more information that you can document and categorize for others. And so she would travel to distant places, study insects, draw them very meticulously, and all for the purpose of publishing them in these scientific books that were all about the topic, insects, and what they eat and their life cycles. And so what you'll see very common in these types of botanical drawings here is everything's at different stages. So you have to compile a lot of information about your subject, that someone who is also a researcher and interested in these things could just look at it and they could say, oh, okay, I can see what the larva looks like. I know what the pupa looks like. I know what the adult butterfly looks like. And oh, look, I can see what they eat. And I can see that this particular butterfly likes the leaves, but also perhaps the whatever seeds or whatever flowers from this plant. And so you see a compression of time, right? You get everything in the life cycle of this wonderful little guy. And she was obviously a very proficient artist, but what are her scientific contributions from her art? And she, like I said, was really one of the first scientists to really observe insects in particular. insects, and I really like this factoid because I enjoy insects, but I don't like spiders, and I've definitely called them this. But before was this impulse to study insects very scientifically and document them, they were still called the beasts of the devil, which is kind of was what I definitely call spiders when I see them. And they not much was known about insects. Where did they come from? And there was this belief that they actually just generated spontaneously from the earth, from the ground, that's just where they came from, not just kind of where they populate, because they're so small. And these studies, these botanical drawings, detailed the metamorphosis of caterpillars into butterflies and proved that no, they don't just come out of mud. They have actually a much more complex life cycle that is very interesting and useful for scientists, as well as artists. And so that's her scientific contribution. Then the next very famous artist scientist went a little bit of a different route, actually. So Samuel F.B. Morse. This is an example of one of his paintings, the Gallery of the Louvre, and it's a painting of people and paintings within the Louvre Museum in France. Well, he actually began as a painter, and he wanted to have a career as an artist, and he wanted to make great history paintings, just documenting great narratives in the history of different histories of human activity. Well, he wasn't super successful at that. His interest, a combination of just maybe not commercially successful, but also it was kind of one of those things where he said, I'm not really that into it. Maybe it's more of a hobby, not a career. Well, Samuel Morse would then go on to pursue an interest in the early field of electromagnetics. And if you've heard of Morse code before, this is the man who created Morse code, which why was it groundbreaking? Because it allows for really early electronic communication. And his first testing of the telegraph, his invention of doing this, he dazzled the world. In 1844, when he sent a biblical line, "What hath God wrought?" in Morse code. So if Morse code, maybe some of you know Morse code. I've always wanted to learn it, but it's a series of pauses, of dashes, and there's a frequency that is associated with words. And so he sent this line from the Capitol in Washington, D.C. to Baltimore. And I think it's kind of funny that he said, "What has God wrought?" Because there's this idea that, he's inventing something new, this electronic communication, which is just like, thinking about that in 1844 was probably mind-blowing. When text messaging came about in the early 2000s, my mind was blown, and I thought that no way is this going to catch on. Little did I know. So it's kind of like what are we bringing into the world through these new inventions? But of course, Morse code, huge invention for especially thinking about boats communicating with each other, SOS calls, right? Very, very groundbreaking. And then we have the artist scientist, a little bit closer to our time, but still kind of far away, for thinking about the 1930s. In the world of neuroscience, we have Santiago Ramon y Cajal, and he was a Spanish-born artist, but also scientist, and he's often considered to be the father of modern neuroscience, and he actually won the Nobel Prize in 1906 for his research on the nervous system. In particular, he was the first neuroscientist to suggest that brain cells existed, that they are a thing, and that our brain is composed of these cells, and that they connect to each other, and that's how those impulses are traveling through our brain through this network. And so he created these wonderful paintings, drawings of nerve cells that really helped to envision how they interacted with each other, what they looked like, and very scientific and useful, just like the botanical drawings, but also very, very beautiful in itself. I love this image so much. I actually just want to display it. So like I tell my sister, I mentioned she's in neuroscience. And I should probably text her this image because she'd really like it. So next we're going to switch gears, right? So first we've seen that historically artists, scientists often are the same, one and the same, and it interacts with each other, those knowledges. Well, what are the effects of having a very scientific understanding of how the human eye internalizes those neurons, right? That we look at information, it goes into our optical nerve, our brain makes sense, right? It has to make sense and order everything that we see. For us to not get disoriented and get dizzy, right? Well, artists who are really interested in that very scientific way, practice of viewing that humans do, to change our perception, right? That using optics to mess with perception and make us do a double take of, whoa, what am I looking at? Which is a very powerful tool. And here is an example of a very typical use of the trompe-l'oeil. That is a keyword, which is just a French word that means deceives the eye. And the whole idea of trompe-l'oeil, typically in painting, is to make the eye totally think that what they're seeing is real, right? Especially on a two-dimensional surface, such as a canvas, right, that you would paint on. That is a two-dimensional surface. Well, trompe-l'oeil wants you to deceive it that you think it is actually a three-dimensional space that exists in your world, and that you could actually go into it and things in it can come out. And I love this painting, this trompe-l'oeil painting, for a couple reasons. Number one, it's a really great example of trompe-l'oeil. As you can see, what we're looking at is a painting of a painting frame, and we have what we would expect in a frame is the actual painting, and it lives in its own space, and we live in our own space. But here, the artist is drawing this young boy, this young man, who is literally stepping out of the frame, almost as if he is entering into our world. And our mind, even though we can rationalize, say, oh yes, I know it's not actually a person, but you can get tricked, right? And there are some really good uses of trompe-l'oeil that are amazingly realistic, that you really do a double take. So I highly recommend, Googling trompe-l'oeil and seeing all the examples. But it is a method of tricking the eye. I also like this painting too because of the title, Escaping Criticism, and how this is very much a demonstration of when you are getting criticized and feeling a little anxious about it, and you can see his face is very anxious, that you really do want to crawl out of your own skin. Maybe you all have experienced that before, that you literally just want to go under a rock or just jump out of a window. And so I like this because it is playing with this idea of, this painting is trying to escape criticism by not being a painting. And I think that's just an interesting little mind thought. So that's trompe-l'oeil, one tactic that is in history of in art of messing with optics and perception. The other types are using illusionistic techniques. And maybe some of you have heard of M.C. Escher before, very famous for these types of illusions that really make your mind go, huh? What am I looking at? And being really confused. And this is a woodcut print called Sky and Water 1. And it is this blending of sky and water. We have on our north and south pole here a very clear depiction of a goose. This could be a goose, a bird of some type. So that's sky. And then we have a very clear representation of a fish. And notice in all of the levels, we slowly have our bird, we slowly have our fish get a little bit more simplified, less detailed, a little bit more abstract, until they reach this center where they seem to be both at the same time. They have become one. And so, where is the boundary between the bird and the fish, right? Very much messing with our sense of perception that our eye really wants to separate things that we see, right? That this is closer to me than that. That thing is separate than this, right? Versus if we start seeing a world where all of the shapes and objects are blurring together, we start to get a little disoriented. And this effect that he's using is another keyword, and that's called tessellation. And the definition is when a shape is repeated over and over again, covering your plane without any gaps or overlap. So one of the methods that he is using to mess with our perception and our optics is putting all of these transitions very close together. We would have a totally different perception if he spaced these fishes and these birds further away. Our mind would still try to be able to individuate everything, and we'd be like, oh no, like this is weird. But the strong effect happens when it's tessellated, when you are repeating things over and over and putting them close together. Another very classic MC Escher, I think this, if you do know of Escher, you probably are, this is what you've seen, these impossible, I like to call them impossible spaces because, excuse me. So in these impossible spaces where he is messing with our sense of continuity, and just like separation, our eyes want to find continuity between points, say in the distance between two things, right? Judging distance is how we are able to maneuver in our environments and not bump into things or fall down. And he's really messing with our sense of being able to follow a continuous line. And he makes it actually kind of impossible for us to find that separation, right? You can look at these stairways and you can follow them, and they do actually have a continuous line, but it's an impossible space. This is and that becomes very trippy and funky, and that's why a lot of people really like Escher's impossible spaces. And then we have a more modern version of what Escher's doing. He was working in the 30s, the 50s, and then when we get to the 60s, in a similar way of really thinking about how art using basic formal elements, right? Line, black and white, how close are your patterns together, to really, really, really mess with our sense of orientation and disorientation. And no other modern movement during the 60s encapsulated this desire to really mess with optics and perception, and that's op art, which basically it just means optical art. It's just the slang, op art. And a lot of these paintings looked like this, and this is Bridget Riley's Blaze 4 from 1964. And I won't stay on it too long because I actually find op art, it makes me very queasy, and I've been to exhibitions of just this type of art, and I literally had to close my eyes because I thought I was going to puke and fall over. And the whole idea of op art is using simple contrasts. It doesn't have to be light and dark, but there has to be a strong contrast between your colors and the positive and negative space, because that is how it is doing what it's doing, right? And notice when you move your head, everything is moving. Everything is moving. It's flickering probably for you. It looks like these are radiating outward and inward, or maybe spiraling depending on how you're moving your head. And nothing is moving on this is a flat 2-dimensional space, but just by messing with the patterns and then using the circles and the line and the thickness and thinness of the line, it's creating all of these opportunities where your brain can't exactly compute what's happening. But in the only way that it can do that, it's the only way that it's making sense of what we're seeing is showing that movement. It's showing that, oh wow, there's this dynamic thing that's happening, and it's only in the eye. But now I have to switch gears because I have started to get very queasy looking at op art. And the final use of optics and perception is not necessarily meant to fool our eye and how eyes work in a very scientific sense. This is using the optics of science and technology, of machines, of new machines created to basically be better than our eyes, right? Because the human eye is not an X-ray, it's not a telescope, it has a limitation. We can't see underneath things, but we can invent technology that can do that. It can actually be a super eye, but still basically using the same ideas of an atomical eye, but in a machine. And we can use these machines to do a lot of things for us, right? If we're thinking about medicine and microscopes, very important, astronomy, telescopes, but also for art, right? Very useful, especially X-ray machines. And this is a really great example of how a simple X-ray scan of a painting can give us new information about a painting, but also change the whole interpretation of a famous painting. And so here we have 2 images of Johann Vermeer's painting Girl Reading a Letter. Vermeer, very, very famous Dutch Renaissance artist. And these type of images are very common of these middle-class Dutch people in these very quiet images of them doing very everyday things in their richly decorated apartments, houses. But if we're thinking about X-rays, so look, the one on our right, is the painting that had existed for a long time. This is the one that art historians said, though, this is the painting. This is the original painting. But during a routine conservation checkup, right? Just like human bodies, paintings need checkups to see how they're doing, if they're deteriorating, if they have mold. Well, it was X-rayed, and that X-ray machine showed that there was an underpainting. There was actually there was a painting that was at some point a part of the painting that was covered up deliberately. And the one on your left is what they found. This was actually the original painting. This was augmented at some point in time, and they can tell, right? Because then you can take samples of the pigment of this versus the pigment of the paint covering up this image, and they were actually many decades different. So it wasn't something that Vermeer did. It was something that someone else did. And that means that they didn't like whatever Vermeer had in the background. And it was this painting of a Greek mythological figure that is a Cupid, right? And we all know Cupid as he's the one that it signifies love and attraction, the son of the goddess of love, Venus or Aphrodite. And so why would someone want to cover up Cupid? Well, if we think about the context of this scene, a young girl reading a letter, well, if we have an image of Cupid behind her, we get a sense that, well, what kind of letter is she reading? Well, it probably might be a flirtatious, amorous love letter. And depending on the context that you're in, you might not want such a salacious or such a flirtatious image. And so some scholars believe that maybe that was the issue, that this being a scene of a love letter, might have been off-putting. So they said, well, let's just paint out Cupid, and that now it's a very ambiguous scene. Now it could be any letter. It could be a family member's letter, a friend's letter, and so it becomes a lot less, sexy, right? The sexy element is taken out. So a really great example of how, us creating optical machines can change our perception of just artworks in and of themselves.